Hello, this is Group 9. Our project that we are working on is force convection in a double tube heat exchanger using nanofluids with constant and variable thermal physical properties. I am Michael Coder.
I'm Caleb Buter.
I'm David Hozan.
And Thomas is not currently here.
Yep. Next slide, please. So here's a study. Here's an overview of the study that we were assigned. What the purpose of it was to enhance force convection, thereby reducing the overall thermal resistance. It also increases the thermal conductivity by utilizing aluminum oxide as a nanoparticle. The study was conducted using laminar flow. There was varying volume fractions of the nanoparticle. It varied from 2.5% all the way up to 10%. What this did was increase the Reynolds number. What the study concluded is that the viscosity of the fluid is very, very sensitive to temperature. An increase in the volume percentage fraction of the nanoparticle increased heat transfer, and throughout all of it, the Nusselt number is mostly unaffected.
Right. So Michael and I were planning on taking charge of the ANSYS simulation, and we've gotten a fair bit better at familiarizing ourselves with the interface of ANSYS, and we've done some research on examples that we found on the internet, on YouTube mostly, and those links are there for anybody who wants to overview them and see what's going on there. And we anticipate a couple of problems. The biggest problem that we have come across is that the difference between the examples on YouTube and the study example that we have. In the study example, they didn't have inlet and outlet areas or flows at all. They just took a section of a tube exchanger for their simulation. So we're going to have to figure out how to do that. And also the fluid property changes of the nanofluid is going to be difficult to modulate as well, because every example that we've come across so far hasn't had varying fluid property changes. And as far as the coding, Thomas was supposed to be working on this, but he hasn't been responsive since Tuesday. But it is very similar to the heat pipe, double pipe heat exchanger coding problem that we were assigned. It's only very small modifications here and there are needed for the code. The biggest difference is instead of working from fluid properties to Reynolds to the other equations, you're working from Reynolds to fluid properties to the other equations. But that shouldn't be too hard to figure out.
Lastly, I will be working on the fiscal aspect of starting a company in Pomona to produce these heat exchangers. Initially, I wanted to focus on a facility and quickly realized that facility costs vary a lot based on size and hookups, equipment. Right now, we can't determine what type of space we would need because we hadn't done any other studies, so we can't currently estimate facility cost. I next looked into heat exchanger, either procurement or manufacture, and quickly realized that while material costs aren't a huge obstacle, labor costs are very high in Southern California. And with a little bit of research, found a lot of companies offering heat exchangers of all types, sizes, of all materials. So it's right now looking like we'll be getting the manufacture of the heat exchangers outsourced and just storing completed heat exchangers to combine with our nanofluid. As far as the nanofluid manufacture, the nanoparticles, the aluminum oxide powder is actually widely available from different science and industry providers. So we'll probably be purchasing it. Right now, the price I found is about $220 per kilogram, and that's for a 50 nanometer sized particle. And then the distilled water that'll be mixed with, I found prices for distilled water as well, and then also found machines that will distill water. And for about 2 to 3 shipments of water, about 270 gallons, you could purchase a machine and then you would only have the inputs of commercial of tap water and power. So it looks like we'll be buying the heat exchanger, buying the particles, and developing our own distilled water source, and then still looking into mixing and shipping and all the other things.